Hi, so in the next 5 minutes, I'm just going to give like an overview of how API dispatching is implemented in different scientific Python projects. So here API means like a Python library API. I don't mean like web API or anything. And instead of package and like library, I'll go with library, okay? And so what is dispatching? You might have like seen the word dispatch used while ordering. So like it kind of means that your package has left something to go somewhere. So like in a physical sense, it goes from location A to location B, and in API dispatching, it's going from a library A to library B, the function call. And like it is not like you are importing the different library B and like calling the function in it. Like, um, you add an extra parameter like dispatch to, and like if it is equal to library 2, you go and find the function in library 2 and call it, and like make the uh, parameters so that it suits the API of library 2. So it's not this, it is something like this, that user gives a call to library 1, and then library 1 automatically converts it into something that library 2, or like whatever library the user wants to use, it converts into something that that library can understand, and gives the output accordingly. So we don't, but like why do we do it and how do we do it? So let's see an example of NetworkX. So NetworkX is a graph analysis library, not these kinds of, but these kinds of graphs with nodes and edges, and they can be anything you want them to be. And it has a pretty simple API. You can create a graph object and then add nodes from this list and add edges from this list, and you get a graph like this. And betweener centrality just tells you how important a node is. So you can see that the middle node is 1, so it has the highest betweener centrality. Um, but when you take like a million node graph, it is going to take forever. So that's the problem. And it is happening because NetworkX is pure Python, and we don't want to like switch to another language because it's simple, but it's also slow. So what should we do? And like other people kind of have like workarounds on this. Like they would uh, create a subset of algorithms that run on GPUs like cuGraphs, and like but it's none of those alternatives are like comprehensive like NetworkX, and it is also like difficult to switch to a different library just for like one or two functions. So dispatching is a solution. So what you do is that you dispatch the function call that NetworkX receives to a different library like cuGraphs, which is like graph analysis on GPUs. And so these were like small subsets of algorithms that NetworkX had, and then we kind of sort of created a nice ecosystem with this dispatching mechanism. So we know like why do we do it for improving the performance, and how do we do it is it's like this is the user API part. We can like skip it, and so basically we use like something called as Python entry points, which like this is how you define it. And we Python entry points like let you uh, get like group all the backend packages that are installed in your system. Like you can just use this entry point function that the import lib library has, and then you get the name of the backend from the user, and then in that entry point you can like store object. Like entry point has like these a group, a name, and a object reference, and this object reference is basically like a namespace of all the functions that the library supports, and also the conversion functions. Like if cugraph supports uh, graph object instead of a NetworkX graph object. It will have that functions to convert between those two graphs. And then we convert the graph. If the user has not already given us a graph, then we convert. Otherwise, we skip that step, and then we just take that namespace and call the backend function, and we output the whatever the output we get. And usually the rule is that whichever, like if we get a NetworkX graph, then we should return a NetworkX graph, and if we get a graph, then return a graph. And there is like more to it, but like these are the main steps of dispatching, and you can have multiple other steps based on the library. And these are like some of the backends, and there is being some development in scikit-image also, like in that it is like images instead of graphs. And uh, these are like some of the links you can go and see. NumPy dispatching is a bit different from NetworkX and scikit-image dispatching. It's purely type-based and not entry point based. Thank you.